Tangent planes and linear approximation. We're going to talk about two theorems here. Differentiability implies continuity theorem, and the continuity of first partials implies differentiability. Because when we're talking about tangent planes and linear approximations, we talk about derivatives, so it's necessary to talk about differentiability and continuity here. Okay, so let's talk about theorem 4.6 first. It says, let z equal fxy be a function of two variables with x0 and y0 in the domain of f. If xy is differentiable at x0, y0, then f of x is continuous at x0, y0. So what this is implying here, it says if xy is differentiable, or fxy is differentiable at x0, y0, then fxy is continuous at x0, y0. So this simply says if the function is differentiable at a point, then it's continuous at that point. Now, theorem 4.7, continuity of first partial derivatives implies differentiability. This says, let z equal fxy be a function of two variables with x0, y0 in the domain of f. If fxy and fx and fy all exist in a neighborhood of x0, y0, then are continuous at x0, y0, then fx is differentiable there. So what this is saying here is they're saying if fxy, fx, fy all exist in a neighborhood of xy, of x0, y0, and are continuous at x0, y0, then they're differentiable. So if the partials exist and are continuous, and if they all exist, including fxy, around x0, then they're differentiable. So it's really getting at the idea if the partials are continuous, then we can talk about differentiability. So I just wanted to mention those two theorems because they come up here and there. Like with a certain problem, I might ask you, oh, is this problem continuous at x0, y0? And using this theorem, if you can show that it's differentiable, like for the first one here, at that point, then you can say it's continuous. Then you don't have to go through all three of those conditions for continuity. Sometimes that's difficult to do. Or if I ask you about differentiability, if a function is differentiable, if you can take the first partial derivatives and they're continuous, and they all exist in the neighborhood, including fxy, then we can say it's differentiable. And sometimes that's a lot easier to do than to actually differentiate a function to see if it exists. So that's why I'm kind of bringing these two theorems up.